Hi there, and welcome to this lecture on process flow diagrams, equipment summary tables. My name is Marina Milicic. Let's next look at the information which should be provided for heat exchangers on an equipment summary table. As you can see, heat exchanger equipment summary tables can be pretty detailed, so we'll go through this table step by step. The first and possibly most important piece of information is the type of heat exchanger. Keep in mind that ChemCAD or Aspen will not choose a type of heat exchanger for you. You must select the best type based on cost, stream properties, and stream conditions. So I'd like to give you an overview of the main choices you have for this type of equipment. There are 13 main varieties of heat exchangers you can choose for your process, and they each are most appropriate based on specific process requirements. Very briefly, I'll go through some of the main characteristics and options for each heat exchanger type. The most common type of heat exchanger used in the chemical process industry is shell and tube. There are three main types of large shell and tube heat exchangers: fixed head, floating head, and U-tube. Fixed head heat exchangers feature tubes which are fixed on tube sheets inside a shell. Hot or cold fluid enters the tube side of the heat exchanger, while the opposite fluid, either cold or hot, flows to the shell side. Floating head heat exchangers are very similar to fixed head, except they feature tubes which are on a floating head, which allow them to expand and contract. This animation is an exaggeration of the movement of this floating head and the expansion and contraction of these tubes. U-tube heat exchangers feature U-shaped tubes which allow for some expansion and contraction and allow fluids to flow more easily through the heat exchanger. The benefit of using these types of heat exchangers is that they can accommodate high flow rate streams, a wide range of heat exchanger areas, up to 1,000 meters squared, a wide range of temperatures and pressures, and do it cheaply. The benefits of floating head or U-tube versus the cheaper fixed head heat exchanger is that floating head and U-tube can expand and contract to accommodate large temperature differences between the two streams and between the inlet and outlet streams. The U-tube heat exchanger is more appropriate for viscous fluids compared to fixed head or floating head. If you need a smaller heat exchanger, one for lower flow rates and areas less than 200 meters squared, consider a double pipe, multiple pipe, scraped wall, or spiral plate. Double pipe heat exchangers are named appropriately since they feature a tube inside a tube and are one of the very simplest heat exchangers you'll encounter. Hot or cold fluid enters tube side of the heat exchanger, while the opposite fluid, either cold or hot, flows to the shell side. Multiple pipe heat exchangers build on the tube-in-tube design by placing several tubes inside a tube instead of just one. Just as with shell and tube heat exchangers, hot or cold fluid enters and exits tube side, while the other fluid moves through the shell. Scraped wall heat exchangers feature one or more tubes with motor-driven rotating scrapers inside them to move fluids which are viscous or may have suspended solids. Fluid enters the heat exchanger tube side, is scraped by the rotating blades and exits, while the other fluid moves through the shell side. Spiral plate heat exchangers are a unique design where a hollow plate, which acts as either a hot or cold channel, is rolled up loosely. Imagine a hollow plate rolled up in a coil such that it's not touching itself. A plate rolled up in this way allows one fluid to flow through the hollow plate and another to flow through the void space which was created by loosely coiling the plate. This is a simplified representation of the cross-section of a spiral plate heat exchanger after the hollow plate is rolled up. The red area represents the coiled hollow plate, and the blue areas represent the empty space between the coiled layers. Hot fluid usually enters in the center, flows through the coiled hollow plate, and exits at the exterior of the coil. Cold fluid flows through the void space, usually entering at the periphery and exiting in the center. These heat exchangers are all appropriate for areas less than 200 meters squared and are good to use for viscous fluids, but scraped wall is particularly useful for fluids with precipitates and crystals, and spiral plate is known for its efficient use of heat transfer area and compactness. The next three heat exchangers are oftentimes used when a stream needs to undergo a phase change, such as evaporation or condensation. These heat exchangers are a bayonet, reboiler kettle, and spiral tube. While other types of heat exchangers, especially shell and tube, are also frequently used for phase changes, these three offer unique features appropriate for specific process requirements. A bayonet heat exchanger is a lot like a shell and tube, but without the shell, which means it can be moved around and installed inside any appropriately sized vessel. Tubes are fixed to a tube plate only on one end. To understand the flow of fluid inside this heat exchanger, let's look at an individual tube on a bayonet heat exchanger. Notice each tube has a smaller one within it, which means there's an inner concentric cylinder in the center, and the area surrounding it is the annulus. High-pressure fluid enters the inner tube, usually through the center, then moves to the opposite end before reversing direction and exiting. The inlet fluid is kept separate from the outlet fluid through the use of two tube plates. So zooming out to look at the heat exchanger as a whole, fluid enters within the inner concentric tube and exits from the annulus. Whatever fluid is inside the tank or vessel is the shell side fluid, and it transfers heat with the outside of the tubes. A reboiler kettle heat exchanger is very similar to a shell and tube, except that it features a unique shape which accommodates overhead vapor space, so this heat exchanger is good for boiling fluids shell side. A spiral tube heat exchanger is just a coiled tube inside a shell. The coiled tube allows for more heat exchanger area between the tube and shell side fluid, which can be effective for condensing shell side vapor into liquid. Let's briefly examine when you would use each of these types. Bayonet is typically used when a heat exchanger needs to be easily installed and taken out of a process unit. It's typically used for evaporation or recovering heat from hot gases. Bayonet heat exchangers are also designed to expand and contract due to differences in stream temperature. A reboiler kettle heat exchanger is best for boiling a liquid, such as for a distillation column. The shape facilitates better control of the flow of vapor compared to other phase change heat exchangers. A spiral tube heat exchanger is best for small applications with areas up to 50 meters squared, low pressure fluids, and for boiling or condensing almost any fluid. It has a compact design which is especially effective for viscous, corrosive, or fouling fluids. The next two types of heat exchangers are used for very efficient heat transfer for a very wide range of required areas. These are plate and frame and plate and fin, sometimes called a compact heat exchanger. Plate and frame heat exchangers are very important, efficient units, but they can be difficult to understand and visualize, so let's look at how these function. Heat transfer occurs between plates in a plate and frame heat exchanger. These plates have 4 holes in them for the inlet and outlet of the hot and cold streams. Plates are separated and sealed, usually using a gasket. If we now place another plate on top of this one which has the gasket and press them together, a channel is formed where fluid can come in and go out. If we now take this top plate and place a gasket on it, and then add another plate on top, we can flow the other fluid through this channel and it will transfer heat across the plate. We can continue adding gaskets and plates and alternating flow until we have our desired heat exchanger surface area. Let's look at an expanded view of what this would look like. If we decide the channels formed by these gaskets will contain hot fluid flow, then these pairs of plates pressed together will be responsible for containing the flow of hot fluid. If we decide then that the channels formed by these gaskets will contain cold fluid flow, then these pairs of plates pressed together will be responsible for containing the flow of the cold fluid. So the hot fluid will be entering from here, moving up in between every other plate, and then exiting at the top. The cold fluid will enter from the top, move down every other plate, and exit at the bottom. Now looking at the final assembled plate and frame heat exchanger, you can see these plates are pressed together and held by a frame, and that hot and cold fluid enter and exit on the same end of the heat exchanger. This compressed plate design allows for maximum heat transfer between fluids using a minimum volume. In the next lecture, we'll look at how the plate and frame heat exchanger differs from the plate and fin and air-cooled heat exchanger. We will also discuss the process of properly selecting a heat exchanger type. Thanks for watching.